Hi class. So we're going to look at now is how to name alkanes. And so we have 3 alkanes over here on the left. And so let's just start with the top one. Top one is probably the most straightforward because we just got to count up and we have 1, 2, 3, 4, 5, 6 carbons. And so 6 carbons is hexane. Okay? So really straightforward, but what I would do is remember you've got to commit to memory these different carbons. So if it's 1 carbon, it's methane, ethane, propane, butane, pentane, hexane. So make sure you commit those to memory, and I'd probably memorize up through 10. All right, as we go forward, it gets a little more challenging. We still want a number. Now, remember, you want a number from the side that gets us to a substituent the fastest. And so what we want to do is find the longest continuous carbon chain. And so in this molecule, it goes right through the middle. Now remember, it doesn't always have to go through the middle. It can kind of come up, down, swerve, twist around, kind of like a maze. But as long as it's continuous, it's our fastest. Now, we have a choice to number from one of 2 sides. We can number from the left like we did above. And we're going to get the same number total, so we're still going to get 6. Or we can number from the other side. And the reason I'm going through this is that the way we're going to decide which side to number from is whichever gets us to a substituent the fastest. So if you notice these 2 methyl groups here, these 2 lines sticking out in black, they're not part of this blue that I highlighted, so that parent chain. These are considered substituents, so let's mark those in this yellow. So we have these 2 here. And so what those are is our methyl groups. All right, so these are going to be our methyl substituents. And so whichever groups we get to the fastest is the side we want. So we actually want the red numbering. So I'm going to draw a line through these because we actually don't want them. All right. Might have been better just to erase them. All right, so now what we want to do after that is actually just number it. So it's going to be hexane. And the way we're going to do the 2 methyl groups is, remember, if we have 2 of them, we have to use the prefix di. And then it's methyl. All right, and the last thing is we always have to say the number. So in this case, they're both on position 2. So it's going to be 2,2-dimethyl. And let me just highlight that so we can get a little better. All right, so it's 2,2. And the 2 comes from the fact that it's on this 2 carbon. All right, there's 2 of them, so that's why we use the term di. So it's dimethyl, and then the hexane is still part of our parent chain. All right, one last one. Let's do the same thing. Now, we kind of have that same idea that we've been doing, where we can find the parent chain right through the middle. Now, on this case, we want to do the same thing we did before. So we're going to number from the right, and that's because it gets us to the substituent here at the 2 position. If we number it on this side, it'd be 1, 2, and then 3 would be the quickest number we get to. Since we get to something faster numbering from the right, that's why we'll start from that side. All right, 5 carbons is pentane. And remember, these are names that you just want to commit to memory. You need to know methane, ethane, so all the way up through 10. So I would just commit those to memory. Now, the same as we did before, we have these 2 substituents. So both of those are still our methyl groups. And so we're going to put that in the front. There's 2 of them, right? 1 here, 1 here. And so we're going to make that dimethyl. And we still have to number them. So one of them is on the 2 position, and one of them is on the 3 position. So it's going to be 2,3-dimethyl pentane. And we just put it together. All right, I hope this was helpful.